morning. This is Dr. S. Subalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. Today, we are going to perform a lecture come design thinking video on the course Matrices and Calculus, and now we are going on to the topic of Green's Theorem. So first of all, what is Green's Theorem? Before that, we will explain the design thinking stages. The first step of design thinking is what? Empathize. Next is define. Next is ideate. And so we are going to study Green's theorem using these 5 stages of design thinking. The first stage is empathizing stage. In Green's theorem, how we are implementing this empathizing stage? First of all, we are going to imagine an environmental engineer studying a circular lake. What do you mean by a circular lake?
A lake is in circular shape. It has the equation of a circle x square plus y square is equal to r square.
Okay, what is a circular lake? It is just a lake which is in circular shape, which is in the shape of a circle. So we can imagine lake as a circle here. That is what we are going to imagine, like an environmental engineer. What do we observe here? What do they observe? The water is rotating inside the lake. Obviously, inside the lake, the water will rotate. Second thing is they need to measure the total circulation. How much circulation happens inside the lake is to be measured. So this is the empathizing part of design thinking. Next is, after the observation, we will have a question like, how much total rotation is happening inside the lake? How much total rotation is happening inside the lake? Can anyone answer?
Rotation in the lake can't be measurable, so it is infinite times.
Yes, rotation inside the lake cannot be measured at all, and it may happen infinite times inside the lake because water flows according to the circular motion or in wavy motion or somehow. So this question arises. So how we implement Green's theorem on it and how we will take it up to the next level, we will be moving on to the next slide. So this is our defining stage. As our girl explained, the equation of the lake can be equalized to the equation of the circle. Here we will consider the radius to be 2. Therefore, your equation of the lake is here as x square plus y square is equal to 4, since the radius is considered to be 2 units. So we need to calculate the total circulation of water along the boundary of a circular lake. So our defining stages, we are going to calculate the rotation of water along the boundary of the circle and not inside the circle. Only the boundary things are to be calculated. So what is our goal here? We have to find the circulation using an efficient mathematical method. So what will be that efficient mathematical method? Obviously, we are studying about Green's theorem, right? So Green's theorem is the obvious case of application. Next slide. So this is our ideate stage. What are the possible approaches to compute our equation of the lake or circulation of the lake, which is directly calculate the line integral, which means along the boundary only we are calculating, no? So we can directly calculate the line integral around the boundary or using vector calculus theorem. You can use the vector calculus theorems like Green's theorem or Gauss-Leibert's theorem to measure the flow along the boundary. So here we are going to apply this Green's theorem. We choose Green's theorem because it simplifies the boundary calculations into area calculations. What is it given here? It just simplifies the boundary calculations which we are in need of into area calculations. It is nothing but we are just taking the circumference of the circle and the area of the circle on either sides of the Green's theorem. Okay, moving on to the next slide. So we model the water velocity as the F vector. Here F vector, we will be considering 2 of the ratios. Here are m and n. Those will be taken as minus y and x here. So this represents the circular water motion like swirling. Swirling is nothing but the rotation of the water inside the lake. So here are some of the different boundary points set up towards the equation of the circle, with which on hand we will be moving on to the next slide. So for prototyping stage, we have a girl to explain the stages because we knew how to apply the Green's theorem already. So we have the equation of the lake and the values of m and n. So we have Raghavi to explain this prototype stage. Start.
So line integral over c into m d of x plus n d of y is equal to double integral of r dou n by dou x minus dou m by dou y into dx by dy. Here m is minus y and n is x. 1 and dou n by dou y is minus 1. So dou n by dou x minus dou n by dou y is equals to 2.
Next slide. Now the line integral becomes double integral over r 2 into dx dy. Thank you, ma. So this is nothing but 2 into the area of the lake. What is this? This is nothing but double integral over the region r dx and dy. This is nothing but the area of the circle. So we have mentioned it as area of the lake. What is area of the lake? We already know it is pi r square. Here your r is 2, therefore it is pi into 2 square, which is equal to 4 pi. Now what is our actual question? It is twice the area of the lake, which means twice the 4 pi, which is equal to 8 pi. So this is how we calculate the rotation of the water inside the lake along the boundary line. So our answer here is 8 pi. Next slide. So this is the testing stage. So what is our interpretation here? We have found the line integral to be, it is 8 pi. The value here is 8 pi. And the interpretation here is the total circulation inside the lake is 8 pi. This is the value using Green's theorem. So this confirms. What are the things this confirms is the water rotates uniformly inside the lake. It rotates uniformly, which means it will have a natural flow and general flow here. And the Green's theorem gives a simpler and efficient solution. Rather than using other types of methods of solving the equation, we can use Green's theorem in vector calculus to solve the line integral very easily. This will be the effective method also. Next slide. So conclusion. This is our conclusion. By applying design thinking concept, we understood the real world problem, which is the equation of a lake and the total circulation inside the lake, and defined the circulation measurement. We have defined it already and selected the Green's theorem. In the ideal stage or prototype stage, we have selected Green's theorem using our counter corrections, and we built a mathematical model using Green's theorems LHS and the RHS, which is line integral on the LHS and the area integral, surface integral on the RHS, and we have verified the result. So this is what design thinking approach gives us as a mathematical model. Next slide. So what does this design thinking helps? Design thinking helps us connect mathematics to the real world applications like fluid flow analysis. So here we have measured the water flow along the boundary of the lake, so it can be applicable to the fluid flow analysis also. Thank you. This is how we measure or we interpret design thinking in our mathematical modeling. Thank you.